what complex numbers are?
I equals negative root 1, I squared is 1, and then I to the cube root is negative 1, right? And then
I square would be negative 1, because if I is
Negative 1.
square root of negative 1, right? Then
Okay.
I square has to be negative 1.
Okay.
So let me pull
One
up our handout over here. Okay, so if you guys can see this. Yeah, basically this would be the definition to remember for DI. And then if, of course, if we take a square on both sides, then you end up getting I square equals negative 1. So this would be the imaginary part, but when we are talking about complex numbers, we're actually talking about complex numbers that have the both real and the imaginary part. So A would be the real part and BI would be the imaginary part. And if you actually just look through this definition, then they're telling you if the B value were to be 0, then basically A plus BI would be a real number. If B was not equal to 0 and you had both A and BI, in that case, we would basically say it's an imaginary number. And then they are talking about if you only had the number in the form of BI, which of course means A would be 0, and your B value is not going to be 0, then that's when we say you have a pure imaginary number. So just basically the idea that you're taking the both real and imaginary and putting them together is what makes it a complex number. So you can basically think about complex number as being your larger set. And then when we look at that set, we can actually break it apart into two subsets, where one of the subsets would be real numbers and the other one would be imaginary numbers. And of course, we're familiar with real numbers because most of the time, that's what we're working with. So in this section, we're basically looking at working through different operations with complex numbers. So addition, subtraction, so division is what we would be working through. So when you're talking about in order to imaginary, get into multiplication. Basically with multiplication, we're kind of going through this whole example over here, and you can look through that, but I usually find that going with the FOIL method is probably the easiest thing to do. So you can use basically any type of product you are doing between two complex numbers. You can basically just use the FOIL method and you will get to your answer. If you remember any of your other multiplication formulas, you can definitely use those, like we talk about in this case, multiplying with the conjugates. So if you're multiplying with the conjugates, then basically remember it's the square of the first term minus the square of the second term. You can use that, or you can basically just use the FOIL method. So multiplication, now the quotient, where you're trying to divide these, is where the idea of complex conjugate comes. So again, if A plus BI is the original term, then its complex conjugate is going to be A minus BI. And this actually kind of comes down from this rule of where we multiply just regular conjugates and we get A square minus B square, our product. If you actually multiply complex conjugates together, because your I square value becomes -1, this product basically ends up becoming A square plus B square. This concept is actually used a lot when you are dividing two complex numbers with each other. So of course this will work for multiplication, but you will notice when we get into division, we always multiply by that complex conjugate. So whatever was your original denominator, we multiply both our numerator and denominator by a complex conjugate when we are trying to simplify these quotient of complex numbers. So those were some of the examples that I wanted to look at. And then the last thing we'll talk about is the quadratic equations. And you know, we had actually talked about this when we were doing college algebra. So we had seen some examples where when we solved our quadratic formulas, we of course ended up getting imaginary numbers as part of our solution. So we're kind of bringing that whole idea in here. And then this is an interesting example where you're multiplying two numbers which are going to have negative inside the radical. So what happens when you actually do a product on these? So this would be kind of a neat example to look through. So again, when you get a chance, I would definitely ask you to look through the video for this, but let's go ahead and talk about the examples that I wanted to look over in this section. So this will be from our textbook. And this one, the first example we're actually looking at is number 14. So our example here is basically just asking us to write this complex number in the standard form. Now, when we're talking about standard form, we're talking about basically this form over here, a plus bi. That's what we call as our standard form. So number 14, how can we write that in the standard form? Basically, that means we have to rewrite that square root of negative 18. So any ideas on how we can do that?
That's complex, so it's not standard. Oh, that's right. Oh, you think it is? I don't know why you got that though. I just have. Oh.
Okay, so what do you think?
Would it be 2 minus 18i?
Yeah, so you do want to separate that negative from the 18 itself, so you can write the square root of negative 1 as I, and then you will be left with square root of 18. Now, can we simplify that square root of 18?
Yeah, done. No.
Is there anything we can bring outside from that 18?
6 maybe?
6 wouldn't be a perfect square.
Not that one. 3 root 2?
Yeah, very good, because you can rewrite 18 as 9 times 2, and then square root of 9 would come outside as 3. Very good, yeah, so you would rewrite this as 2 minus 3i square root of 2. So that, again, 2 would become your real part, and then, of course, 3i square root of 2 becomes your imaginary part.
Cool.
That makes sense?
Yeah.
Yeah, okay, very good. So let me see if you guys can try number 20. And let me see what answer you can come up with. So number 20.
9 squared. Is negative 1. Root 4. So then can root 4 be back different tables. So then if we just
So where would you go ahead and start with this one?
changing the I squared into a negative 1.
Okay. That would give us -2 times -1. And then what do you have?
2 plus 4i, and then can you simplify the 4i even further, or would that be just where you end?
No, that would be just it, because we really couldn't do much with 4i unless you went back and replaced the I as a square root. And they're just asking us to write this in the standard form of a complex number, right? So
Yeah.
you just need to stop right there. So yeah, it was just a matter of clearing up that I square and changing the sign. Alrighty, very good.
Nice, nice, nice.
See, how about, okay, so we're looking at number 30, and the instructions here are perform the operation and write the result in standard form. So again, we're looking at number 30 over here. So let me see what answer you come up with.
I got 15 plus 26i.
Yeah, so this was the one where we were talking about where you just combine the real parts together and combine the imaginary parts together. So yeah, you will get 15 plus 26i. So the addition subtraction, I think, is pretty straightforward, but do you guys have any questions?
No.
Okay, alrighty.
It smells like Home Depot.
Let's look at, and what it's asking us to do here. Same thing, perform the operation and write the result in standard form. So we're looking at number 32 here. This one, of course, is multiplication, right?
Mm-hmm.
So let's see, number 32. This is where I was talking about, like, you know, if you use FOIL, that's probably going to be the most straightforward way of multiplying this.
Mm-hmm.
So again, let me know once you have the answer for this.
No, that's right. Oh yeah. Oh, and you can combine them. Mm-hmm. Okay, I get 11 minus 41i.
11 minus 41i. So of course we've got 21 from here. negative 35i from here, negative 6i from here, which will of course give you that negative 41. Now, what did you guys do over here?
The I turned into, or the I squared turned into -1, and then we
Yeah, so
combined it with.
that's right. So that's the only crucial thing to remember is that I square will always need to be changed into -1 because that will then become the real part, which of course will combine with the real part from the first term. So these go together, which gives you the 11i as your real number part. And then of course, combining these two imaginary gives you the negative 41i. So that was the only thing I wanted to make sure you would remember to change that I square into -1.
Cool.
Nicely done. Okay, so that was now how about this one here? Number 38.
Square.
So when it says the whole quantity squared, what do we end up doing?
Foiling.
Yeah, very good. So basically the same idea, you can do FOIL.
I got 9 minus 40i.
Say that one more time.
I got 9 minus 40i.
Okay, 9 minus 40i. Okay, I believe that is correct because you will end up doing 25 minus 16 from here, right? Because again, I squared would be -1, which will end up giving you.
Yeah.
And then this will give you positive 40. Yep, positive. Okay, you said minus 40i though. Let me see. No, I already took a negative sign there, so I didn't need that negative there. Okay. That should be a minus. Very good. So let's look at 42, and this one is actually saying write the complex conjugate for the complex number and then basically multiply by the conjugate. So we are looking at number 42 over here.
Write the complex conjugate.
So what will be the complex conjugate for this guy?
Would it be -3 minus I root 2?
Yeah, very good. So you're just changing that sign
Oh, okay.
in the middle, and then they're asking us to multiply. So yeah, -3, and then this guy becomes minus I square root of 2. All right, very good. Now you can use FOIL over here, obviously, or you can use, let me see if I can pull that guy back up. This process right here that we were looking at. When you multiply the complex conjugate, you're basically doing a squared
plus
b squared. Whichever one you think you want to go with. And what does that give you?
9 plus 2. Because it's root 2, right? Would it be 9 plus 2i?
Okay, so you are taking the first term squared,
It'd just be 11.
plus the second term squared, right? So you actually don't need to bring the I with it at all because
Oh, okay.
it's a squared plus b squared, right?
So it's just 11.
It will be 11. Yes, very good.
Yes, I got it right.
Alrighty,
I don't know.
very good.
It's just.
And you know, even if you would have tried FOIL method, you should have still come to the same result.
Yeah.
Alrighty, very good. Are you guys doing okay so far?
Yeah.
Let's try an example for our quotient next. Here they're basically saying write the quotient in standard form, and we're looking at this problem over here, number 50.
60 minus 7i minus 2i.
So this is where, remember, you take the conjugate of the denominator and multiply both the numerator and denominator by that conjugate. So what are we looking at as a conjugate here?
1 plus 2i.
You good? So again, on the denominator, you can use that same rule of a squared plus b squared, and the numerator, of course, will need to do a FOIL on that.
So I got 20 minus 1i over 5.
20 minus.
Oh wait, not one, not that. Sorry.
Okay.
Um, 5i minus 5, or no, not minus 5i. Yeah, no, plus 5i. Sorry.
Okay, no problem. So you're changing this to 20 plus 5i over 5?
Yeah.
Okay. All right, let's see. So yeah, because you're adding basically 6 with positive 14, which should give you 20. And then positive 12 minus 7i, so that will give you positive 5i. And then on the denominator, you of course have 1 plus 4, which adds up to 5. Now, what happens with complex numbers, since we want to write them in the standard form, you don't want to leave that common denominator. So we will go ahead and separate that denominator and write it as 20 over 5 plus 5i over 5. And then when you simplify that, what will you get?
4 plus 1i.
Yeah, very good, because the 5 on the I imaginary side will cancel out, and then 5 goes into 20 4 times, so you will write this guy as 4 plus I, and that will be your final answer. And you know, even if these did not cancel out, you still want to separate your real part from the imaginary part, okay?
Okay.
Alrighty, very good, guys. Nicely done. Any questions on any of these?
Nope.
No, okay. All right, let's look at. Right here. So they are saying, again, same thing, write the complex number in standard form, but this is where we are actually looking at number 60 to see what happens when you take a product of these two numbers that basically have negatives inside their radical. So you are multiplying square root of -5 with square root of -10. So before we multiply, we actually want to convert these into complex numbers, which means you want to bring that negative sign outside. So what will we rewrite each of these numbers as?
Would it be I root 5 and I root 10?
Yeah, very good. Yeah, we want to bring that negative sign outside as the imaginary number I. So this will become I square root of 5 and I square root of 10. Okay, very good. And now we can go ahead and multiply these.
Would it be I squared 5 root 2?
Alrighty, let's take a look. So you're multiplying I times I. We're of course multiplying 5 times 10, which will give you square root of 50. And then you said 5 root 2?
Yeah.
Yeah, very good, because you're rewriting that 50 as 25 times 2, where the 25 will come outside as 5. You have square root of 2, but then what happens with the I square?
It becomes -1.
There you go. I square will become -1. So this will actually just end up becoming negative square root of 5. -5 square root of 2.
Cool.
So what happens in this case is, since we convert them into imaginary numbers first and then multiply, you will actually always end up with a negative answer when you do a product. Because, you know, if you do it the other way, if you just go ahead and multiply -5 and -10 first, then of course those two negatives would end up becoming positive, but that's actually incorrect in this form, because technically these are complex numbers, so we need to rewrite them with I first, so we don't really do this. So just kind of keep that in mind. Okay, so let me see. Okay, so this next example is going to be one where we talk about using the quadratic formula to solve these quadratic equations. So we are looking at number 72 over here.
60.
You guys remember the quadratic formula?
Yeah.
What value do you use for B?
4. -4.
-4. Yeah, make sure you take the sign with the number. So right when you see that negative show up in your radical, that's when we know we're getting imaginary solutions, right?
Mhm.
All right, so let me see what your final answer comes out to be.
I got 1/8 plus I root 11 over 8. And then 1/8 minus I root 11 over 8.
Okay, so how did you simplify that 176?
The 176, I put the I on the outside of the
So bringing
square
the
root.
negative outside, okay?
And then 176 simplifies down to 4 root 11.
Yeah, because it's going to be 16 times 11 for 176. So the 16 will come outside, of course, as your 4. And then this is where we, of course, need to separate our denominator. So 4 would, of course, go into 32 8 times. So very good. Yeah, you will end up with 1 over 8 plus or minus, and that would basically be square root of 11 over 8, and then you have your I. Okay, very good. Nicely done. Any questions on this one?
Nope.
So this is your quadratic formula using to solve quadratic equations. Now, let me see. Okay, now we just want to look at if we wanted to simplify some of these expressions here. So again, your instructions are simplify the complex number and write it in standard form. So how about number 80 over here? How could you simplify this?
Does that just become negative I?
Okay, so tell me what you did.
Well, because I squared is -1, but then 2 1 more power. Oh wait, would it just be 1 then? Oh, I don't know. Actually, I don't know, Mr. Ruka.
Why don't you try simplifying it and see what you get? So you're kind of on the right track. You want to separate that third power into the second power and the first power. So what will happen when you do negative I raised to the second power?
It just becomes -1.
Okay, so let's think about this. We are looking at, we know negative times
Oh, it
negative
just
would
becomes
become,
1.
yeah, positive, and then the I square would still make it negative, but because we have a negative coming from this second part, it will end up becoming actually a positive I.
Haha, okay.
So this is actually something that always happens with these exponents on the number I or even negative I. So basically here, like I said, I negative times negative will end up becoming positive, but then I square itself will bring this -1, and then this negative with that negative ends up giving you a positive I. But what if we change that a bit, and let's look at 86 over here, which is now negative I to the 6th power. What do you think will happen with this guy?
Does it just become -1?
Okay, so tell me again, what did you do?
I broke it up into 3 separate I squared.
Okay, so like that?
Yeah,
Okay, and then each one of these negative I square is giving us what?
-1.
Very good, yeah, so you end up getting -1 basically to the third power, and that ends up giving us -1, right? Because two
Yep.
of the negative ones will become positive, but we still have one more left behind. So yeah, very good. It will become -I. Alrighty. And I think that was it. Okay. Now, when we actually get into 4.3, we will be talking about the complex plane, and we'll be doing a little bit of graphing and stuff. But what I want to do is, if possible, I would ask you guys to make sure you finish working through your homework for 4.1. Just make sure you are comfortable and confident working through the complex numbers, because of course when we get into 4.3 and 4.4, we're just going to be using complex numbers to basically help us solve all of this. Now I think 4.3, I'm not sure if we'll be able to do 4.3 and 4.4 on Thursday. I'm going to try and see. We'll see how long those lectures come out to be. Because 4.4 is actually not a very big section, but let me see if we can get both of them done. If not, we'll definitely do 4.3 on Thursday. I'll try, like I said, if we can do 4.4 also, and then that will only leave us with chapter 6 for next week. So you are basically looking at, as soon as we get done with chapter 4, you will have your exam for the combined test for chapter 3 and chapter 4. And then once we finish chapter 6, and there's only 2 sections in chapter 6, and then we'll be ready to get into our final exam. So I just want to make sure that you are staying on top of your homework. So if possible, I know you said you hadn't started yet, but go ahead and finish your chapter 3 so you know you don't forget all that stuff. And like I said, go ahead and do your homework for 4.1 at least, so that you're ready for 4.3, 4.4 for the next class.
Okay.
Okay. Anything else you guys had questions about?
Nope.
Doing okay so far?
Yeah. Have you been able to talk to any of the other students and why they haven't been here?
I emailed them, but I haven't heard anything. I'm not really sure what happened to them, because they kind of just disappeared from class.
That's so weird.
Yeah, and some of them up until beginning of last week were still keeping up with their homework. I haven't seen if anybody got started on chapter 3 and 4 at this point. So I do need to go and actually see if they're still doing their homework or if they've just stopped working on the class, because I know it's been really challenging for some students.
Oh, yeah.
And it's been pretty hard because some of them have had to pick up extra work shifts and stuff like that. So I don't know if that's something that's kind of getting in the way, but I'm hoping I'll hear from them maybe sometime this week.
Mm-hmm.
Okay. And you guys doing okay overall?
Yeah, we're doing okay.
Okay, very good. All right, guys, so this is it for today. Like I said, we'll try and do 4.3 and 4.4 on Thursday, okay?
Alrighty.
All right, you guys be careful. I'll see you on Thursday.
All right, bye.
Bye, take care.